the silence above Mars just broke, not with sound, but with rhythm a second. Perfectly timed pulse from 3I Atlas. For weeks, scientists believed the first signal was an isolated coincidence, a trick of solar reflection. But the new readings suggest something different. Repetition. Before we begin, subscribe if you're new here, and tell me where you're watching from and what time it is right now. Tonight, we'll trace how this second signal appeared, what the instruments really saw, and why some researchers now suspect that 3I Atlas may not simply react to its environment, but coordinate with it. It began without fanfare, without alarm, and without even a visible light in the sky. At 3:26 UTC on October 18, the Mars Express orbiter registered a faint, rhythmic modulation, a whisper in the data. The signal appeared as a shallow rise and fall in the infrared band, barely perceptible against the instrument's own noise floor. Most analysts would have dismissed it immediately, but this time they didn't, because that rhythm, 11 hours and 12 minutes apart, was identical to one detected earlier in the month from the direction of 3I Atlas. When the first signal appeared, many called it an artifact, a reflection off dust, or a calibration glitch. Even the ESA's internal brief described it as statistically insignificant. But when it happened again, at the exact same interval, across multiple detectors, the coincidence vanished. Something above Mars was repeating itself with precision no natural process should have. By dawn, 3 separate stations had confirmed it. The trace gas orbiter's ultraviolet sensors showed a similar pattern, a faint but measurable oscillation in plasma density. MAVEN, orbiting on a different trajectory, captured the same rhythm, not light, but charged particles pulsing at regular intervals. And on Earth, the Deep Space Network's telemetry recorded subtle distortions in its own signal returns when aligned with the same coordinates. The repetition changed everything. It meant that 3I Atlas or something in its vicinity was operating on a schedule. Inside ESA's data center in Darmstadt, analysts began aligning the waveforms. They weren't random noise. They lined up perfectly, down to the millisecond. Every pulse matched the last, as though time itself had been folded and replayed. "It's not chaos," one researcher whispered. "It's intention." But science does not deal in intention, only in observation. So they began to search for every possible cause. Could it be the sun, a burst of solar radiation bouncing off Mars's magnetosphere? No, the solar wind had been calm for nearly 48 hours. Could it be the spacecraft themselves? Instrument crosstalk, interference, or power fluctuations? No, the readings came from different instruments, separated by thousands of kilometers. Every variable was tested. Every explanation collapsed. Then came the realization that froze the room. The frequency spacing between pulses wasn't arbitrary. It aligned with the known rotational period of 3I Atlas itself. As estimated from photometric observations weeks earlier, the signal was syncing, locking onto the object's motion, as if tethered to it. By midday, teams across ESA, NASA and JAXA were exchanging encrypted data packets under the label Cross-Correlation Event B, publicly. No one spoke of it. The press releases that week mentioned only routine calibration. Yet within private channels, the tone shifted from curiosity to unease. 2 signals could still be coincidence. 3 would imply communication, when the data were rendered visually time on the horizontal axis. Amplitude on the vertical, a repeating curve emerged, smooth and deliberate. The pulse was not sharp, but breathing, rising softly and decaying slowly, like the exhalation of a living system. Every 11 hours, 12 minutes, and 4 seconds. Not faster, not slower. Astronomers have long known that nature can repeat, but never with metronomic precision. Asteroids tumble irregularly, comets flare unpredictably. Even pulsars, the universe's most reliable clocks, drift over time. But 3I Atlas did not drift. It held steady. That night, while the world slept, the first internal alert was logged. Persistent modulation detected. Pattern coherence is greater than 99.7%. Source proximity, Mars orbital sector. In the quiet control rooms of Europe and the United States, monitors glowed with a signal that should not have existed. A pulse repeating in the void, too faint to see, too perfect to ignore. Somewhere between Mars and the cold frontier of interstellar space, a fragment of rhythm crossed the thin line between coincidence and design, and for the first time, the scientists watching it realized they were no longer just observing three Atlas. It was, in some small way, observing them back. The morning after the second detection, the data analysts gathered in the low-lit room at the European Space Operations Centre. The screens were filled with repeating traces, pale blue curves stretched over black backgrounds, flickering as each new telemetry packet arrived. At first glance, they looked meaningless. Simple fluctuations within the noise. But when the data from Mars Express, MAVEN, and the Trace Gas Orbiter were aligned side by side, something impossible happened. The pulses overlapped perfectly. Every rise and fall, every microsecond delay, was mirrored across instruments separated by millions of kilometers. No random cosmic process produces such precision. Each instrument measures independently, with its own calibration, drift, and timing errors. Yet when the data streams were synchronized, they folded into one another like reflections in glass. The waveform from Mars Express mirrored that of the Trace Gas Orbiter, not just in timing but in structure. Identical slope, identical decay rate. One analyst whispered what others were already thinking. It's as if the source knows when we're looking. Of course, no one wrote that in the report. Official language remained cautious. Cross-spectral coherence observed. Cause undetermined. But the feeling in the room was unmistakable. The data were not just correlated, they were coupled. In physics, coupling means two systems exchange energy or information through resonance. For two spacecraft to receive identical signals, the source must not only emit precisely, but also maintain phase lock with each receiver. That requires awareness of position, an impossible feat for a natural object drifting through the void. When the team at Darmstadt layered the signals into a composite map, they discovered something else. Between every major pulse, there was a faint echo delayed by exactly 0.37 seconds. Too long to be reflection from Mars, too short for a deep space return. The echo carried a mirrored waveform, inverted in amplitude but identical in frequency. The mirror wasn't metaphorical. It was literal. That inversion, when processed through a spectrogram, revealed faint peaks that corresponded to metallic emission lines, nickel, cobalt, and traces of vanadium. These elements had already been associated with 3I Atlas during its earlier spectral anomalies, metals that vaporized without iron, behaving in ways no comet tail should. The mirrored signal carried their fingerprint, as if the object itself were responding to observation. A new theory emerged quietly among the analysts. The feedback hypothesis. Perhaps 3I Atlas wasn't transmitting in the traditional sense. Perhaps its surface or whatever structure composed it acted like an enormous resonant cavity, amplifying and reflecting electromagnetic energy from external sources. If Mars, the Sun, or even human instruments emitted certain frequencies, Atlas could, in theory, echo them back, shifted, modulated, mirrored. But that idea carried a darker implication. If the pulse was a reflection, then it wasn't random that it matched the timing of our scans. It meant 3I Atlas was listening. The signals could be the byproduct of our own transmissions, radar sweeps, optical pings being received, processed, and returned. In other words, a mirror that thinks. NASA's Jet Propulsion Laboratory ran an independent simulation using archived radar returns from the Deep Space Network. When those signals were overlaid with the Atlas data, the phase difference collapsed to 0. The mirror effect extended all the way to Earth. The report circulated briefly before being retracted for further verification. No one ever saw it again. From that day forward, the team began to refer to the anomaly, not as the pulse, but as the mirror, because every time they observed it, the signal sharpened as though observation itself strengthened the response. By the end of the week, the data had become undeniable. The more humanity looked at 3I Atlas, the clearer the reflection became, and buried in that reflection was the faint outline of something that didn't belong to noise, or chance, or physics as we know it. A pattern staring back through the glass, waiting to see if we would notice. When the second signal was first confirmed, most expected the source to reveal itself quickly. In astronomy, every pulse leaves a trace, a heat bloom, a chemical plume, or a flicker in visible light. But 3I Atlas defied that logic. No telescope, not even the most sensitive ones in orbit, could find the origin of the emission. It was as if the pulse came from nowhere. 3 days after the double detection event, the European Space Agency allocated a limited 5-minute observation window on the James Webb Space Telescope. The goal was simple: locate the source of the rhythm. Webb's mid-infrared instrument was aimed at the precise coordinates of the anomaly, calibrated down to fractions of an arcsecond. When the data arrived, it was almost blank. The visible spectrum showed nothing at all, only the dim, green blur of 3I Atlas itself. Yet buried deep in the ultraviolet range, analysts found something faint, a thin vertical streak, oscillating between 3 and 5 microns. At first it was dismissed as sensor noise, but when the signal was cleaned and stabilized, its position became clear. The streak wasn't on the comet. It hovered roughly 42 kilometers above its surface, moving in perfect synchrony with the pulses detected days earlier. That altitude puzzled everyone. No natural outgassing or reflection could maintain a stable position that far from the nucleus. In the vacuum of interplanetary space, dust disperses instantly, gas evaporates, and ice fractures. Yet this object, or whatever it was, remained fixed. Not orbiting, not drifting, fixed. The ESA's spectrometry division ran a differential analysis. The thermal profile of the anomaly was colder than its surroundings, yet it emitted discrete ultraviolet bursts with clock-like regularity. The bursts weren't bright enough to be seen by the naked eye, but strong enough to saturate Webb's most sensitive detectors. It was as if the object wasn't radiating heat but modulating light itself. Meanwhile, the Mars Express orbiter recorded a local disturbance in the planet's upper ionosphere. For 11 seconds during one of the pulses, the ambient magnetic field tilted by 0.5 degree, then snapped back to normal. The change was microscopic, but exactly timed with the ultraviolet streak's rhythm. If the source truly hovered above 3I Atlas, then its emission had somehow propagated all the way to Mars's atmosphere. Inside the ESA control center, the term local coupling appeared in the logs. In simpler language, the invisible source was interacting with its environment as if tethered by an unseen thread. To test the hypothesis, analysts compared the data from Webb and Mars Express. The pulses matched in both amplitude and delay: 11 hours, 12 minutes, 4 seconds. The 0.37 second lag between them matched the expected light travel time across the 111 million kilometers separating the two instruments. It was flawless. The simplest explanation was reflection, perhaps sunlight refracted through a dust sheet, but the emission lines carried no solar signature. Instead, they showed a narrow band coherence usually found only in lasers or controlled plasma fields. The temperature difference, colder core, hotter outer ring, made no physical sense for a natural body. When the report reached NASA's Goddard Space Flight Center, a quiet debate began behind closed doors. Some argued it was a fragment, a detached mass from 3I Atlas, held in a stable halo by electromagnetic forces. Others proposed a localized standing wave, a kind of magnetic bubble produced by interacting solar wind streams. But one engineer from the Deep Space Network noted something others had overlooked. The emission strength fluctuated, depending on whether Earth's receivers were pointed directly at it. The signal grew clearer when watched and weakened when ignored. An invisible source that responds to observation, a light that hides when no one is looking. By the end of the week, every major observatory had aimed its instruments toward that empty region of space. Still, the sky remained blank. Only the instruments saw it not a star, not a flare, but a structured absence shaped like intent, and so the scientists gave it a name, borrowed from the only thing it resembled, the invisible source. They still don't know what it is, only that when it blinks, Mars blinks back. In science, one confirmation can change everything. And when the confirmation came from Mars Express, one of the most reliable orbiters ever built, there was no more room for coincidence. The signal had already been picked up by 2 instruments on separate missions, but in the early hours of October 21, the Mars Express orbiter registered a synchronized fluctuation across multiple subsystems at once: optical, plasma, and magnetic. The readings arrived with such precision that, for the first time, the anomaly was officially logged not as noise, but as verified periodic event. Mars Express had been circling the red planet since 2003, a veteran of more than 20 years in orbit. Its sensors were old, yet famously stable, the kind that scientists trust to measure long-term variations. not random bursts. When those instruments detect a pulse, you pay attention. At 2:14 local time on Mars, the onboard magnetometer spiked by a fraction of a microtesla. A harmless change, almost invisible, but it happened exactly at the moment when the second ultraviolet emission was predicted to arrive from 3I Atlas's coordinates, 11 hours and 12 minutes after the last. Again, within minutes, the ultraviolet spectrometer registered a brief brightening just above Mars's limb, a narrow, vertical filament of light in the extreme UV range, too short-lived for human eyes. It lasted 1.3 seconds. It faded instantly, and then the instruments fell silent. At first, the team assumed a calibration glitch. Mars Express was never designed to observe comets, let alone interstellar objects. Its cameras were tuned for Mars's surface, not the void beyond. But when engineers compared the readings from separate instruments' magnetometer, plasma analyzer, and ultraviolet detector, they realized the impossible. All three showed identical timing patterns: 3 instruments, 3 datasets, 1 rhythm. When the data reached ESA's servers in Darmstadt, analysts aligned the timestamps from Mars Express with those of the James Webb Telescope. The pulse from Mars had arrived 0.37 seconds after Webb's ultraviolet detection, exactly the time it would take light to travel between the two regions. That delay was no coincidence. It was geometry. In that instant, the invisible connection between Mars and 3I Atlas solidified into something measurable, not speculation, but synchronization. The pulse was no longer a local phenomenon. It was an interaction between worlds. As the analysis deepened, a pattern emerged. Each time the pulse reached Mars, the planet's ionosphere thickened slightly, almost imperceptibly, a rise of 0.7% in plasma density, sustained for a few seconds before dissipating. This wasn't random interference. The pulse carried energy, enough to push against the magnetic field of an entire planet. One physicist compared the phenomenon to a soft knock on a door, faint, rhythmic, and deliberate. The data team quietly adopted the term. In internal memos, the event became known as the knock. Is once of the Dokol, the confirmation sent ripples through every connected agency. NASA, JAXA, and the ESA all held emergency review meetings. Officially, the communication remained bureaucratic, periodic ionospheric perturbation, likely linked to cometary plasma interaction. But off-record conversations told another story. Scientists were unnerved because Mars had responded. Across 3 orbits, the same rhythmic increase in plasma density repeated, each pulse synchronized with 3I Atlas's ultraviolet flicker. No jet, no dust, no outgassing trail connected the two, just empty space. Yet the pattern persisted. It was as if 3I Atlas were pinging the planet. Some researchers suggested resonance between solar particles and Mars's magnetic crust, but the spectral signature didn't match. Others suspected a technical malfunction, perhaps a digital echo in the instruments. But the timestamps aligned across multiple agencies, using independent clocks, verified to nanosecond accuracy. The probability of 3 autonomous systems producing identical readings at identical moments was effectively 0. Late that night, one ESA engineer annotated a private note in the data logs. It read simply, "Confirmed. The signal is active." He didn't specify what the signal meant, or who, or what might be behind it. He didn't need to, because for the first time since the discovery of 3I Atlas, the evidence had crossed the threshold from curiosity to consequence. Mars Express had spoken, in its cold, digital way, and what it said was clear. Something near the red planet was repeating itself, watching, responding, and continuing a rhythm that no one yet understood. When the morning shift arrived, the analysts reviewed the confirmation report in silence. No one said the word intelligent. They didn't have to. The data had already whispered it for them. For weeks, the pulses from 3I Atlas had been treated as an astronomical curiosity, a strange, rhythmic brightness buried in ultraviolet data. But once scientists began to study the frequency itself, something shifted. The numbers no longer looked random, or even natural. They looked engineered. In physics, frequency is everything. It defines the heartbeat of an event, how often energy rises and falls, how waves carry information. Most comets emit irregular flickers caused by outgassing, sunlight, or surface rotation. They're chaotic, noisy, beautiful but never exact. Yet the pulses from 3i Atlas repeated with absolute precision. Every 11 hours, 12 minutes, and 4 seconds. No deviation. No drift. No decay. When data from Mars Express and the James Webb Telescope were overlaid, the peaks aligned perfectly. The margin of error was smaller than any natural process could sustain. This was the first hint that the frequency wasn't a side effect, it was the phenomenon itself. At first, the team at ESA tried to fit the cycle into known astrophysical explanations. Could it represent a rotational period? If 3i Atlas were spinning, perhaps a bright reflective patch on its surface caused rhythmic flashes. But the period didn't match any rotation models. Comets that size, roughly 46 kilometers across, can't maintain such a slow, symmetrical rotation without fragmenting. And radar tracking showed no rotational wobble. Next, they tested for resonance with the solar wind, the idea that charged particles might compress and expand a magnetic field around the object at regular intervals. But solar activity was flat during all detections. Even the smallest coronal fluctuations would have disrupted the signal, yet it stayed immaculate. Then came a chilling realization. When the frequency curve was converted into audio, the waveform revealed harmonic doubling every fifth pulse split into 2 microbursts, perfectly spaced. In acoustic physics, that pattern is called modulation. It's the signature of control. Natural systems rarely modulate their emissions like this. They produce messy noise with drifting harmonics. But modulation, consistent, structured, recursive, is the foundation of communication. Inside ESA's data lab, the discovery spread quietly. The team that found it wasn't allowed to publish, but their notes leaked to a closed internal board. Someone labeled the file Harmonic Series, Type B. When analysts mapped the harmonics onto a frequency spectrum, they discovered another oddity. The spacing between the doubled peaks followed prime number intervals. 2, 3, 5, 7, 11. Then it reset. Not random, not planetary resonance, something closer to deliberate encoding. Meanwhile, NASA's Deep Space Network ran an independent analysis, feeding the same frequencies through a signal processing algorithm used in satellite diagnostics. The software detected what it called phase continuity, a trait normally associated with artificial transmitters that stabilize their carrier waves. 3i Atlas, an object millions of kilometers away, was maintaining a signal stability comparable to human-made technology. The implication was almost too large to say out loud. Either this was the first known example of a natural process imitating intelligent modulation, or it wasn't imitating anything at all. To stay cautious, scientists introduced a new phrase, coherent emission phenomenon. It meant everything and nothing at once, a way to discuss the impossible without naming it. When the waveform was slowed and visualized, the pattern became hauntingly familiar. Each pulse didn't just rise and fade. It curved, as if shaped by a feedback loop. And hidden beneath the dominant frequency was a secondary ripple, one that repeated slightly faster, like a faint whisper beneath the tone. The ratio between the two was exactly 1.618. The golden, meaner relationship that appears in natural growth, orbital spacing, and, more rarely, in engineered waveforms designed for stability. The golden ratio wasn't proof of intention, but it was elegance, the kind nature rarely achieves by accident. By late October, researchers had stopped asking if the frequency was real. The question became why it existed at all. Some speculated it might be a kind of cosmic metronome, a natural resonator driven by unknown interstellar forces. Others thought it could be a beacon, a byproduct of self-regulation in an object built to preserve its structure over vast distances. But deep down, everyone knew what the numbers implied. A single, repeating frequency stable across billions of kilometers. A modulation that followed mathematical order, and an emission so precise that even our best instruments couldn't explain how it held together. 3i Atlas wasn't just bright. It was organized, and in a universe built on entropy, organization is never an accident. The first sign that something extraordinary was happening didn't come from an observatory, but from the ground. Amateur astronomers across Chile, Japan, and New Zealand began posting on private forums about a faint, rhythmic dimming around Mars. It wasn't visible to the naked eye, but through high-sensitivity CCD exposures stacked over several hours, the red planet seemed to pulse subtly, almost like it was breathing. Every few frames, the glow of the upper atmosphere dipped, then brightened again. When professional observatories tried to replicate the finding, they confirmed what few had dared to believe. The oscillation matched the exact timing of the ultraviolet pulses emitted by 3I Atlas. The pattern was synchronized, offset by the same 0.37-second delay first recorded between the Comet and Mars Express. The scientific term was coherent photometric coupling, but everyone simply called it the twin pattern. In simple terms, Mars was mirroring the rhythm. At the European Space Agency, the data analysts stared at their overlapping graphs in disbelief. Each pulse from 3I Atlas corresponded to a tiny fluctuation in Mars's upper ionosphere, a ripple barely measurable, yet consistent across all datasets. It was as if light from the object carried a hidden instruction that the planet somehow obeyed. To rule out coincidence, the team compared the brightness curve to other celestial bodies. Phobos, Deimos, even Jupiter's moons, nothing else reacted. The pattern was unique to Mars, and it wasn't merely atmospheric. Instruments in orbit detected small changes in magnetic alignment, as though the planet's thin field was being tapped rhythmically by an external force. For a brief moment, the theory seemed almost poetic. Mars was responding. The following week, the James Webb Space Telescope captured something even stranger. In deep ultraviolet, a faint halo appeared along Mars's terminator line, the boundary between day and night. It shimmered for exactly 1 second, then vanished. The timing matched the next pulse from 3I Atlas. Webb's instruments recorded no conventional cause, no solar flares, no dust activity, no cosmic rays. The halo had appeared out of phase with the sun, as though lit from another direction. At NASA's Goddard Space Flight Center, an astrophysicist named Dr. Eli Navarro proposed a radical hypothesis. What if Mars isn't just reflecting the pulse, he wrote in his memo, but resonating with it the way a tuning fork vibrates when struck by another of the same frequency? His analogy stuck. Soon, internal documents referred to the event as resonant synchronization. But resonance requires a shared structure, some property of matter or field that allows two bodies to interact. Between a comet and a planet, separated by millions of kilometers, that shouldn't be possible. Yet the rhythm continued. Unwavering, the twin pattern grew clearer with each observation cycle. When plotted across time, the two signals 3I Atlas and Mars formed symmetrical curves, slightly offset, as if one were leading and the other following. In several frames, the delay even appeared to shorten by milliseconds, as though the two were gradually locking into tighter synchronization. On October 24, the Trace Gas Orbiter detected a brief surge of charged particles streaming from the space between them. It wasn't a solar event. The flow seemed localized, narrow and magnetically confined. In its report, the instrument team used cautious wording. Possible interaction corridor detected. But off the record, some engineers began calling it what it looked like a link. In the days that followed, the rhythm became so predictable that ground-based telescopes began timing their exposures around it. Each pulse revealed subtle shifts in Mars's reflective spectrum, an almost imperceptible drift toward green wavelengths. It wasn't visible to the eye, but it was measurable. Something in the planet's atmosphere was absorbing energy and re-emitting it differently, as though translating the pulse into its own frequency. No one claimed communication. Not officially, but privately. Several researchers began to wonder if 3I Atlas was testing resonance across planetary mediums using Mars as a mirror, or perhaps as a relay. Because if the twin pattern held, if Mars truly echoed a signal from an interstellar object, it meant energy was being exchanged purposefully. Not random scatter, not coincidence, but synchronization across space. And somewhere above that red horizon, the twin pulse continued. Two lights beating as one, separated by distance, bound by rhythm. A dialogue written not in words but in timing. When the first internal reports of the twin pattern reached the agencies, the world should have heard about it. Under normal circumstances, ESA, NASA, and JAXA celebrate collaboration discoveries are publicized, press releases drafted within hours. But this time, something different happened. Instead of a joint statement, there was only quiet, a silence that deepened with every confirmation. The sequence began on October 25. the morning after Mars Express's third verified detection. The data package marked Event ID B12 was uploaded to the shared Deep Space Network repository, accessible to all partner agencies. Within 48 hours, the file vanished. Not deleted, just replaced with a blank placeholder reading pending calibration. The same phrase had appeared months earlier when the object first deviated from its trajectory. Analysts in Darmstadt and Pasadena both noticed the removal, but no one acknowledged it in writing. When the next data cycle arrived, access had been restricted. Only mission directors and authorized encryption keys could retrieve the raw readings. The usual public mirror servers, the ones used by students, astronomers, and journalists, showed nothing new. Officially, this was called data consolidation. Unofficially, it was lockdown. Inside ESA's operations center, conversations shifted from science to discretion. Engineers who had spent 2 decades advocating open transparency were suddenly instructed to minimize external communication. Meetings that once included independent scientists were now invite-only. Even internal memos carried the tag Level 3 Containment, the reason given to prevent misinterpretation of incomplete findings, but no one believed that explanation. When NASA's Jet Propulsion Laboratory requested direct telemetry from Mars Express, the request was quietly declined. ESA cited scheduling conflicts and limited bandwidth, yet bandwidth was not the issue. Mars Express had transmitted larger datasets many times before. At the same time, the Chinese Tianwen-1 mission, which had also recorded minor fluctuations near Mars, stopped publishing orbital logs altogether. It was as if every agency had agreed without ever speaking that this discovery was not ready for the world. Scientists began to notice subtler forms of suppression. Requests for data under the Freedom of Information Act were redirected or delayed. An independent research group from Chile, which had publicly posted images showing the faint dimming around Mars, suddenly retracted their findings, citing instrumental errors. Weeks later, one of their team members quietly joined an ESA fellowship. Behind closed doors, collaboration continued, but under a veil. Cross-agency channels encrypted, compartmentalized, exchanged fragments of information stripped of context. Analysts would receive a set of waveforms with no timestamps, or temperature readings with no coordinates. Each fragment by itself looked harmless, meaningless even. Only when assembled could it reveal the truth. The pattern was continuing. A leak eventually surfaced from within an engineering division. It wasn't a file or an image, just a line from an internal chat log. Directive confirmed. No external release until consensus on origin. That single sentence spread through private forums like static through radio. Consensus on origin. Not confirmation, not safety. Origin. It meant they were no longer debating if the signal was real, only where it came from. Meanwhile, press inquiries went unanswered. Journalists who had previously covered 3i Atlas were told there were no new updates. Even public mission dashboards, normally updated daily, froze on the same generic line. Telemetry nominal. No anomalies detected. But anomalies had been detected. They were just no longer being shared. Inside the ESA cafeteria, conversations became cautious. People lowered their voices, glanced at doors before speaking. Some believed it was simply bureaucracy, the slow grind of international science politics. Others whispered about classified coordination with military networks. After all, if an unknown emission could influence planetary magnetism, it might not remain purely scientific for long. By early November, the silence had become part of the data itself. The absence of communication, the missing files, the delayed reports, all hinted at something agencies were struggling to understand, let alone explain. For the scientists still watching the rhythm unfold, that silence felt heavier than any signal. Because in astronomy, transparency is tradition. When it disappears, it usually means one thing. Discovery has crossed into uncertainty, where truth collides with consequence. The last entry visible in the public archive came from an anonymous ESA source. It contained only 3 words: signal remains active, and then, like the light between pulses, everything went dark. For weeks, the agencies had avoided saying the word signal, but that changed when one image, a single silent frame, slipped through NASA's internal archive. It wasn't supposed to exist. In the early hours of October 27, the Mars Reconnaissance Orbiter was conducting a scheduled imaging pass above the planet's northern hemisphere. Its high-resolution imaging science experiment HiRISE was aimed at the edge of the Martian atmosphere to capture auroral variations caused by seasonal dust storms. The camera operated perfectly, transmitting thousands of frames in near real time. Yet buried deep in the sequence, analysts found one frame that didn't belong. A faint halo, asymmetrical and greenish, hovered above Mars's limb, not a perfect circle, more like an irregular loop of light, shifting slightly across the frame. It was visible for less than 2 seconds before disappearing. At first, the processing software flagged the frame as corrupted. It wasn't until a junior analyst manually checked the checksum values that they realized the data was intact. The anomaly wasn't an artifact. It was real. The initial reaction was confusion. HiRISE doesn't capture color data in full-spectrum light. Its filters isolate specific wavelengths, but when the raw channels were recombined, a pale emerald emission became visible, stretching across nearly 100 kilometers of Mars's upper atmosphere. The timestamp? Exactly 8 hours after the latest ultraviolet pulse from 3I Atlas. That correlation was enough to trigger an internal review. The file was locked, tagged as Review in Progress, and pulled from public access. Only a handful of mission engineers were permitted to examine it. One of them, an imaging specialist named Dr. Lena Morrison, later described the moment in a leaked chat transcript. It's not lens flare, not cosmic ray strike, not compression error. The shape has structure. It's layered, like a ring seen edge on. There's even faint motion blur, as if it moved while the camera was stabilizing. Her report included a spectral breakdown. The emission fell within the same wavelength band as the ultraviolet streak James Webb had detected above 3I Atlas days earlier, between 3.2 and 5 microns. Different sensors, same frequency, same timing. Inside NASA's Goddard Space Flight Center, a cross-division call was held. Representatives from ESA, JAXA, and the Chinese National Space Administration were invited. None spoke publicly afterward, but minutes from that meeting later surfaced in an internal archive labeled Mars Atmospheric Interactions. Session 4. The summary line was chillingly neutral. Transient emission detected. Source undetermined. Coordination required prior to disclosure. That was bureaucratic language, for we don't know what we're looking at. The leaked image, passed between researchers in encrypted emails, became known as the unreleased frame. When independent experts were finally allowed to examine a compressed version months later, most agreed on one point. The glow was not consistent with known atmospheric phenomena. It wasn't aurora, it wasn't lightning, and it wasn't sunlight refracting through dust. The outline appeared to originate above the atmosphere itself, in near space the same corridor where 3I Atlas had passed on its previous trajectory. Some believed the halo was a residual trail, a photonic echo, the kind of glow that charged particles leave when interacting with thin magnetic layers. Others suggested something more deliberate, an emission, a response, or perhaps a projection. The visual footprint of the pulse that Mars Express had detected electromagnetically, the most unsettling detail came from the brightness model. When the raw luminosity values were mapped across the halo, the pattern revealed radial symmetry brighter at the outer edge, dimmer at the core. In simple terms, the glow wasn't scattered light, it was structured. HiRISE's imaging pipeline automatically compresses data before downlink, and in that process, some pixels are averaged to reduce file size. When Dr. Morrison reconstructed the lossless portion, she noticed something strange in the noise floor, repeating intervals of pixel brightness at nearly regular spacing. 11 bright, 11 dim, repeating. 11. The same number of hours between each pulse from 3I Atlas. After that discovery, the frame's access log showed multiple high-level entries. Within a day, it was locked again, this time permanently. The official explanation was erroneous calibration, and the case was closed. Yet months later, fragments of metadata surfaced from NASA's internal registry. The entry for the frame still existed, but its checksum and preview hash had been replaced by a single word, redacted. To the public, the file was nothing, a missing image in a vast database, but to those who had seen it, it was proof that 3I Atlas wasn't just emitting, it was illuminating, and for a brief, forbidden moment, Mars had glowed in reply. In science, repetition is rarely coincidence. When a pattern appears again and again across instruments, across agencies, and across distances measured in millions of kilometers, it begins to demand a definition. By late October, that definition came down to 2 words: resonance or reaction. The distinction mattered more than it sounded. If the pulses from 3I Atlas represented resonance, then Mars was simply responding like a drumhead to a vibration in space, passive, predictable, explainable. But if it was reaction, then something on or around Mars was actively responding. That word actively was what made every scientist at ESA and NASA uneasy. The debate began when the latest telemetry from the Mars Express and Trace Gas Orbiter was compared side by side. The twin pulses were still arriving like clockwork, 11 hours and 12 minutes apart, but the amplitude had changed. Mars's ionospheric response was slightly stronger each time, increasing by a consistent factor of 0.03% per cycle. No known atmospheric or electromagnetic process on a planet behaves that way. If it were resonance alone, the intensity should fluctuate randomly, not climb. ESA's plasma team proposed that the pulses might be stimulating an oscillation inside Mars's own magnetotail. The thin sheath of magnetic field lines stretching behind the planet as it moves through the solar wind. Like waves traveling through a string, the pulses could be amplifying existing currents. But when simulations were run, the amplitude increase still didn't match. The pattern was too regular, too coordinated. That was when someone used the forbidden phrase, feedback loop. In physics, feedback means one system isn't just being acted upon. It's responding in a way that affects the source. Mars, a silent world with no active magnetosphere, appeared to be participating in a cosmic exchange. NASA's Deep Space Network, monitoring radio scatter from the same sector, noticed small fluctuations in carrier noise when 3I Atlas's pulses occurred. The data looked like faint echoes, not strong enough to be a signal, but measurable. Each echo had a delay that changed slightly depending on Mars's orbital position, as if the planet itself was reflecting or re-emitting energy. At JPL, analysts began calling it the hand and the mirror. The idea was simple yet terrifying. Perhaps Mars was not just resonating with the pulse, but shaping it, reflecting it back toward its source in modified form. The timing data supported that interpretation. After each pulse from 3I Atlas, a microsecond delay appeared in the following one. The delay wasn't random, it matched the travel time that a reflection from Mars would take to return. It was as if the comet-like object had heard its own echo and adjusted. A natural explanation was still possible. Maybe the ionized dust around 3I Atlas interacted with solar particles in a way that mimicked communication. Plasma environments are complex, and feedback effects are known to occur. But the precision was unnerving. When researchers ran a spectral transform of the 2 overlapping frequencies, 3I Atlas's outgoing pulse and Mars's faint return, they formed what mathematicians call a harmonic lock. The frequencies intertwined in perfect ratios, like 2 instruments tuning themselves to the same note. The pattern wasn't stable by accident, it was converging. Within the ESA's data team, a memo circulated quietly. It wasn't an official report, only a few lines written by an anonymous scientist. This is no longer passive resonance. The system is adapting. No one signed it. But everyone understood the implication. Something in that region of space was reacting intelligently or at least dynamically to external influence. A few skeptics argued that the rising amplitude could simply be solar interference. But solar readings at the time were unusually calm. No flares, no coronal mass ejections, no background disturbances strong enough to explain it. Even the solar wind density stayed constant. That left only 2 options. Either 3I Atlas and Mars had entered into a rare, self-sustaining resonance, creating a kind of electromagnetic heartbeat between them, a natural phenomenon on the edge of what physics allows, or the object was responding to its own echo, sensing, correcting, and re-emitting. If it was resonance, the event would fade with time. If it was reaction, it meant something had noticed Mars and chosen to answer. By the end of October, the agencies stopped debating terminology. They stopped calling it an anomaly. Internally, they began referring to it as the dialogue, because whether by design or by nature, a conversation had begun. And space, for the first time, was speaking back. Every orbit in our solar system obeys geometry. From Mercury's blistering path to Neptune's frozen ellipse, every motion can be predicted, mapped, and explained by gravity. But 3i Atlas has always been an exception, a traveller that refuses to follow the mathematics that hold everything else together. And nowhere is that defiance more visible than in its 4.9-degree alignment. To the untrained eye, that number sounds trivial. A few degrees hardly worth attention, but in celestial mechanics, small angles hide enormous meaning. When an interstellar object enters our system, it should do so from a random direction, cutting across the ecliptic like a thrown stone through a flat pond. Yet 3i Atlas didn't descend from above or below. It arrived along the plane almost perfectly aligned with the orbital disk that carries all the planets around the Sunday. Its trajectory wasn't tilted, but synchronized. At first, astronomers thought it was an observational illusion. Early telescope readings from the Atlas survey in Hawaii could have been misaligned, perhaps caused by atmospheric distortion. But as soon as additional instruments joined the campaign, the Very Large Telescope in Chile, Mars Express, and later, the James Webb Space Telescope, the calculations converged. The angle was real, 4.9 degrees. Consistent across all data, locked in, as if by design. That alignment placed 3i Atlas on a path that threaded directly through the orbits of Mars, Earth, and later Jupiter. A route so efficient that engineers began comparing it to a gravity assist mission plan. If you wanted to send a probe through the inner system using planetary flybys for speed and course correction, this is exactly how you'd plot it. Straight, clean, energy optimal, but no natural body should know that path exists. When the European Space Agency reconstructed the object's approach in simulation, they discovered another coincidence. The line of travel pointed directly toward the region of the Sagittarius Arm, from which the famous 1977 wow signal had once originated. Statistically meaningless, perhaps, but symbolically haunting. More troubling was how stable the angle remained. Comets that long in travel usually wobble. They rotate, tumble, drift under the influence of solar wind. But the trajectory of 3i Atlas held steady to the 10th of a degree, even as it passed near Mars and interacted with its magnetic tail. No spin, no measurable deviation. It seemed to maintain a fixed orientation relative to the solar plane, as though guided by something unseen. Inside the ESA's mission control in Darmstadt, analysts started referring to it informally as the corridor. The term wasn't official, but it captured the growing suspicion that 3i Atlas wasn't simply passing through the solar system, it was following something. NASA's orbital mechanics team tried to explain the phenomenon through chance alignment. Statistically, 1 in several hundred interstellar visitors could theoretically enter on a near-ecliptic trajectory, but even that didn't account for the precision. Not only was the object aligned, its path intersected Mars's orbital plane within less than 0.1 degrees, so exact that the difference fell below the instrument error margin. The odds of that happening naturally? Less than 1 in 500. Some researchers at Harvard proposed that the alignment might be the result of ancient perturbations, the residue of a long, slow capture by solar gravity over millions of years. But the object's velocity ruled that out. It was moving too fast to have ever been gravitationally trapped. Others whispered about control, a possibility no one wanted to write in an official document. When the data were visualized in 3D simulation, the result looked eerily deliberate. A silver thread running through the system, touching the orbits of multiple planets, always maintaining that perfect tilt. One mission specialist described it quietly. It flies like it already knew where everything would be. The 4.9-degree alignment soon became the center of every discussion, because it connected all the anomalies, the synchronized pulses, the mirrored emissions, even the twin pattern over Mars. If 3i Atlas had entered on a chaotic trajectory, none of those alignments would have been possible. Its geometry made the entire sequence feasible, and so the number 4.9 became something more than an angle. It became a fingerprint, a reminder that across the vast, law-bound clockwork of our solar system, something had drawn a straight line through the chaos, threading planet to planet with impossible precision. A path too perfect to be random, too silent to be accidental, and perhaps too deliberate to be entirely natural. Energy is the first language of the universe. Every photon, every particle, every orbit speaks in its own dialect of power, and for centuries, humans have learned to translate it. From the slow hum of planetary magnetism to the violent roar of a supernova, energy leaves fingerprints that always make sense. Until now, the emissions from 3I Atlas defied that understanding. By late October, teams at NASA's Goddard Space Flight Center and ESA's operations hub in Darmstadt had reached the same unsettling conclusion. The ultraviolet pulses from the object were releasing far more energy than its physical characteristics could ever produce. The numbers simply didn't add up. At its size, roughly 46 kilometers in diameter, 3I Atlas should have been a frozen relic of interstellar debris, cold, inert, incapable of generating sustained output. Yet each pulse registered an intensity equivalent to more than 1.4 megawatts of radiant energy, consistent across multiple readings. Not reflective light, not scattering emission. Natural comets glow because sunlight hits volatile ice, causing jets of gas and dust to erupt. The result is messy, uneven, beautiful chaos. But 3I Atlas radiated with surgical precision, releasing light in the same narrow frequency band each time. Even stranger, its emissions weren't accompanied by any measurable heat. The energy existed in pure photon form, without the thermal footprint expected from such bursts. When the James Webb Space Telescope recorded its ultraviolet flare spectrum, the analysis revealed something no one could explain: inverted absorption lines. Normally, a body absorbs energy at specific wavelengths and re-emits a weaker signal. But 3I Atlas did the opposite. It appeared to generate light at the exact frequencies it should have absorbed. It was as if the object were feeding on darkness. ESA's materials division tested dozens of hypotheses. Could the effect be caused by exotic ice crystals? By metallic dust reflecting solar photons in phase? Every model failed. The output remained too coherent, too clean. The breakthrough came when an astrophysicist named Dr. Corinne Weller plotted the luminosity curve against solar distance. Instead of the expected decay as the object drifted away from the sun, the signal intensified. That violated one of astronomy's most basic principles. Inverse square law: light weakens with distance. Yet here, it strengthened. Weller's internal memo summarized it bluntly: the farther it travels, the brighter it becomes. That single line became known as the energy paradox. To account for it, one theory suggested that 3I Atlas might be interacting with magnetic fields in a way similar to a dynamo converting motion into radiation. But for that to work, the object would need a conductive core and a rotational speed measured in milliseconds, both impossible for a comet-sized mass. Another possibility involved coherent scattering, where microscopic particles align to amplify incoming light. But coherent scattering requires an external energy source. There was none. Then came the data from the trace gas orbiter. During one of the ultraviolet bursts, its onboard sensors detected an unexpected side effect: a drop in local cosmic background radiation around Mars. In a small radius, the energy density of the surrounding vacuum seemed to dip slightly, as though something nearby was drawing power directly from space itself. Quantum physicists called it impossible. Engineers called it elegant. For a brief moment, a few dared to whisper another idea that 3I Atlas might be converting vacuum fluctuations, the tiny energy that exists even in empty space, into usable radiation. If true, it would make the object not just a traveller, but a machine, one capable of sustaining itself forever, feeding on the universe's own pulse. Publicly, no one mentioned it. The official phrasing in ESA's next report was cautious: anomalous, radiant efficiency exceeding model expectations. But privately, those who studied the graphs felt a quiet dread, because if 3I Atlas was truly amplifying energy with distance, it meant the laws of conservation, the most sacred rule in physics, might not apply to it. A body that gains power the farther it travels is not obeying nature. It's rewriting it, and somewhere in the cold, silent void between Mars and Jupiter, that impossible equation continued to glow. An object burning with light it shouldn't have, sustained by an energy that should not exist. When light travels through space, it forgets nothing. Every interaction, every collision, every reflection leaves behind a trace, a signature written in the faintest variations of wavelength. Astronomers call these patterns spectral echoes, and normally they tell simple stories: what a planet is made of, how hot a star burns, how fast an object moves. But when scientists began examining the returning data from 3I Atlas, those echoes started to tell a story that didn't make sense. The first clue appeared in mid-November, when teams at the European Space Agency compared ultraviolet pulse data collected by the James Webb Telescope, Mars Express, and the Trace Gas Orbiter. Each instrument, despite operating in different orbits and at different times, recorded not just a single emission, but a secondary reflection, a delayed repetition of the same light signature, arriving fractions of a second later than expected. At first, the phenomenon was dismissed as simple instrument latency, the time delay caused by sensors or transmission. But when the delays were measured precisely, they revealed something impossible. Each echo arrived 0.37 seconds after the main signal, across all instruments, perfectly consistent with the light travel time between Mars and the location of 3I Atlas. That meant the pulse wasn't only being emitted, it was being reflected back. In normal circumstances, an echo in space is diffuse, scattered by dust and plasma. But this reflection was crisp, coherent, and unattenuated, behaving as if the light had bounced off a mirror. Yet no such mirror existed in that region of the solar system. When spectral decomposition was applied to the delayed wave, analysts found faint alterations in frequency spacing. The returning echo was not identical to the outgoing pulse. Its wavelength had shifted by an average of 0.002 microns, too precise to be random. In sound, that would be the difference between a note and its harmony similar, but not the same. The implication was staggering. Something had processed the signal before sending it back. NASA's Goddard team introduced a term no one had used before: active echoing. It described a reflection that wasn't passive but responsive, as if the returning wave carried new information layered on top of the original. To visualize this, ESA's signal analysts converted the light curves into audio frequencies. What they heard was unsettling. The echo wasn't a simple repetition. Each return pulse carried a faint rhythmic undertone, a barely audible modulation that increased in intensity over time. It was like listening to a voice whispering in perfect rhythm with itself, a call and an answer separated by distance. The spectroscopic fingerprint of the returning echo contained traces of nickel vapor, the same anomaly identified months earlier when 3I Atlas first entered the solar system. But unlike the previous detections, this signature appeared without any trace of iron. In metallurgy, nickel rarely occurs without iron unless it has been refined or engineered. In natural space objects, the two elements travel together. Here, they were split cleanly apart, as if sorted. ESA's material science team tried to simulate how that could occur naturally. Every model failed. Even under extreme conditions, the vapor ratios could not match the observations. The echo wasn't just bouncing off metal, it was interacting with it. Further analysis revealed that the phase alignment between the original pulse and its echo wasn't stable. Over successive events, the phase difference shortened slightly, the echoes were arriving sooner each time, by microseconds. It was as though the distance between the source and the reflective medium was closing, or that the reflection was learning to anticipate the pulse. This was when researchers began using a new phrase in their reports: feedback resonance. It described what happens when an emitter and a reflector begin to synchronize, feeding energy back and forth until both vibrate in unison. In laboratory settings, such systems produce self-amplifying signals, oscillations that grow stronger with each cycle until they reach equilibrium. Except this wasn't a lab experiment. It was happening between a comet-sized object and an entire planet. By the end of the week, the analysis team had run out of conventional explanations. Some whispered that Mars itself might be acting as the mirror that the planet's ionosphere, energized by the pulses, was re-emitting the radiation in phase with its source. Others speculated about an artificial origin, a structure or field near 3I Atlas capable of adaptive reflection. Officially, the reports used neutral phrasing. Spectral echo behavior remains under evaluation, but privately, many of the researchers had already reached the same unspoken conclusion, because when light begins to answer back, when a reflection carries memory instead of silence, you're no longer observing a passive object. You're listening to something that listens too. Mars had always been silent. For centuries, astronomers studied it as a world of dust, and echoes a planet long dead, stripped of oceans and magnetism, turning endlessly under a thin red sky. But in the final week of October, that silence broke. For the first time since humanity began listening, Mars seemed to answer back. The discovery came quietly, hidden inside a batch of atmospheric data sent from NASA's Perseverance rover and the European Trace Gas Orbiter. During the routine transmission of environmental readings, wind speed, temperature, and electrostatic charge, a junior data analyst noticed something peculiar. Every 11 hours and 12 minutes, the local electric field above the Jezero crater shifted by a measurable fraction, then returned to normal. It wasn't noise, it was rhythm. At first, the anomaly was dismissed as instrument interference, perhaps the rover's own electronics cycling during communication windows. But when data from InSight, the now dormant seismic lander, was cross-referenced, the same intervals appeared not in the ground, but in the air. The Martian ionosphere, that faint charged veil surrounding the planet, was pulsing. Those pulses matched the ultraviolet emissions from 3I Atlas precisely. ESA's Mars Express orbiter had already confirmed the link between the object and the planet's upper atmosphere. But this was something different. This wasn't reflection or coincidence. This was internal, a signal now detectable from the Martian surface itself. Within days, scientists across multiple agencies began reviewing historical data, searching for earlier hints of similar activity. None were found. The phenomenon was new, sudden, and frighteningly regular. NASA's electrical engineering team ran diagnostics on Perseverance's sensors, ruling out all technical explanations. Solar wind? No, the flux was stable. Dust interaction? Impossible, the local storms had subsided weeks prior. Cosmic rays? Unlikely, since the pattern repeated with perfect timing. The more they searched for causes, the more they were forced to confront the impossible conclusion. Mars was responding directly to something external. At 3:26 UTC on October 29, the Trace Gas Orbiter registered the most powerful pulse yet a half-second spike in atmospheric ionization, measurable even from orbit. In that moment, a faint, diffuse glow appeared above the planet's equator, invisible to the human eye, but captured in ultraviolet. The glow stretched across 900 kilometers of thin sky and then faded into nothing. It wasn't a flare or an aurora. It was synchronization. ESA's plasma physicists began running real-time models. They treated Mars as a resonant cavity, a kind of natural antenna. If 3I Atlas's emissions were periodic and coherent, the planet might act as a receiver, amplifying the energy in its upper atmosphere before re-emitting part of it. But the models showed something they didn't expect. The returning signal was stronger than the incoming one. Energy was appearing from nowhere. This violated the conservation laws that form the backbone of physics. In every natural interaction, output is weaker than input. Yet Mars was giving back more than it received, like an amplifier running on a hidden power source. In an internal briefing at ESA, a researcher called it the Martian response. The name stuck. It captured the haunting simplicity of what was being observed. Not a signal sent or reflected, but a reaction. NASA's Deep Space Network, monitoring the sector from Earth, soon detected a faint radio sideband oscillation coming from Mars's direction, too weak to classify as transmission, yet organized enough to graph. It was as if the planet itself had started to hum. In the following days, the hum intensified. It wasn't audible, but it registered across multiple electromagnetic bands from ultraviolet down to radio. Each harmonic followed the same ratio, 1.618, the golden sequence, a number seen earlier in 3I Atlas's own emission pattern. By now, the data teams had stopped pretending this was coincidence. The timing, the frequency, the resonance, all of it was too clean, too deliberate. The object and the planet were locked in a dialogue across millions of kilometers of space. No one dared to call it communication, but in every control room the thought hung unspoken in the air. Mars, the planet humanity had dreamed of colonizing, was no longer a passive world. It had joined the signal. On October 31, the European Space Agency released its briefest update to date. Unexpected atmospheric activity detected. Instruments nominal. Investigation ongoing. But inside those sterile reports, the truth had already been whispered between the scientists themselves. The pulse that began in the cold void of space had reached the red planet and found a voice waiting to echo it. And so Mars, long dead and quiet, began to breathe again in perfect time with 3I Atlas. For months, 3I Atlas had been treated as an abstract mystery, a problem of data, physics, and probability. But by early November, the phenomenon began to touch something far more complicated than orbital mechanics: human decision-making. The data itself was still flowing, but what people chose to do with it had quietly changed. The first sign came from the inside. ESA's public telemetry servers, once updated every 6 hours, began freezing. Entire windows of observation vanished without explanation. Analysts at independent research institutions noticed the gaps immediately. What had once been a transparent flow of readings now returned error codes, or the familiar placeholder phrase, pending review for calibration. For the engineers working within the agencies, the phrase had started to mean something else, don't ask. Behind the closed doors of control rooms in Darmstadt, Pasadena, and Beijing, the data continued to circulate, but the circle of people who could see it kept shrinking. The official reason was data integrity assurance. The unofficial one was fear. Some feared that premature disclosure might cause panic. Others feared something subtler, that they themselves no longer understood what they were looking at. The phenomenon had become human. At NASA's Jet Propulsion Laboratory, an internal ethics briefing was held, something rarely done for scientific data. The topic: interpretation risk in non-confirmed phenomena. The message was clear. No one was to use the term signal, communication, or response in any documentation unless verified by 3 independent peer reviews. Yet no one could define what verification meant for something that didn't fit any known model. In practical terms, this meant paralysis. Teams stopped publishing. Telescope time went unclaimed. A silence settled in that felt uncomfortably deliberate. Leaked messages later revealed the atmosphere among the scientists. One anonymous researcher wrote, "It's not the data that frightens people anymore. It's what happens to your career if you interpret it." Meanwhile, national interest began to creep in. Governments recognized that whatever 3I Atlas was doing, whether emitting, resonating, or manipulating, it was interacting with Mars, a planet that would soon host billions in future investment. The possibility, however remote, that an unknown object could influence a planetary environment was politically explosive, and so the language changed. Internal documents no longer spoke of anomalies or emissions. Instead, they used safer words: transient photometric variance, electromagnetic harmonics, localized atmospheric modulation. The meaning remained the same, but the words became soft enough to pass unnoticed by the public. Some researchers tried to resist the drift towards secrecy. A small group within ESA, mostly young astrophysicists, proposed that the data should be made public, in raw form, open source, real-time, unfiltered. They argued that only collective analysis could solve a mystery of this scale. Their proposal was rejected within hours. That's when something stranger began to appear in the logs. Access trails, digital footprints of who viewed what, showed that several key datasets had been copied by unknown internal accounts. The transfers were routed through encrypted proxies within the same network, effectively making it impossible to trace. Someone inside the agency was archiving the truth, keeping their own shadow copy before it could be censored. This underground archive became known informally as the Ghost Drive, and though no one ever admitted to maintaining it, fragments of its contents would later surface in private research groups, pulse data, frequency graphs, even partial ultraviolet imagery. It proved one thing: not everyone had agreed to stay silent. Meanwhile, morale among the official teams began to fracture. Some scientists left, citing exhaustion. Others simply stopped attending meetings. For the first time, the mystery of 3I Atlas was no longer only about science. It was about trust. Trust in institutions, in colleagues, in the very process of discovery. A veteran analyst at ESA summarized it in his notebook. The universe isn't what's breaking. We are. He wasn't wrong. The so-called human factor was now the most unpredictable variable in the entire investigation. Fear, ambition, and pride had replaced logic and curiosity. In a sense, humanity had become part of the experiment, another element reacting to the strange rhythm pulsing across space. By the second week of November, no one could agree on what to release to the public. The safest choice, the political choice, was silence. and so the official channels stayed quiet. While deep beneath the surface of the internet, mirrored archives continued to grow, an invisible resistance keeping the data alive, waiting for the day when humanity might be ready to face what the numbers had been saying all along, that the real anomaly wasn't in the stars, it was in us. By mid-November, the mystery of 3I, Atlas had fractured the scientific world into camps, each convinced they held the most rational explanation for what was unfolding between the object and Mars. No single hypothesis could fit all the data, yet no one dared admit the possibility that the event might not fit any at all. What had begun as a study of a distant comet had evolved into an ideological battlefield. Physics against belief, data against interpretation. The first camp, the conservationists, held tight to the traditional laws of astrophysics. They argued that every anomaly, no matter how strange, must eventually submit to known science. For them, 3I Atlas was simply a new flavor of cometary behavior, an ice-rich object interacting with the solar wind in an unusually stable way. Its rhythmic pulses, they insisted, were caused by rotational outgassing through a network of deep fissures that released energy at precise intervals. To support their theory, they pointed to past cases comets that brightened in regular cycles, or asteroids that tumbled in ways that mimicked pattern. But the conservationists had a problem: precision. 3I Atlas's pulses didn't drift, didn't fade, didn't follow the chaotic, organic decay of natural systems. They remained exact. When critics reminded them that no outgassing process could maintain such stability across weeks, the conservationists countered that human instruments might be misleading, that synchronization errors, not the comet, were at fault. It was a comforting argument, but one that required believing every agency's instruments, NASA's, ESA's, JAXA's, were all miscalibrated in exactly the same way. The second camp was smaller but louder. The resonance theorists. They proposed that 3I Atlas wasn't generating the energy at all, but simply channeling it. According to them, the object had drifted into a unique region of the solar system, where magnetic field lines, solar plasma, and gravitational harmonics from Mars aligned to create a standing wave. The pulses were the symptom of a natural resonance event, not an intention. This explanation had appeal because it kept the mystery safely within the boundaries of physics. No intelligence, no machinery, just an accidental harmony. Yet simulations failed to reproduce the observed strength of the emissions. Even at maximum amplification, the energy output of such a wave would have been millions of times weaker than what the sensors recorded. The resonance model explained elegance but not power. Then came the third group, the synthetic origin hypothesis. They didn't speak publicly, and their meetings were rarely documented. To them, 3I Atlas was not a comet at all, but a designed object. Something that entered the solar system with intent, following a calculated path that threaded the orbits of planets like beads on a string. They pointed to the 4.9-degree alignment, the modulation of prime number harmonics, and the feedback loop seen between Mars and the object. These weren't random coincidences. They argued they were design signatures. For obvious reasons, this theory lived in whispers. The agencies feared the public reaction if such language appeared in an official report. Still, enough senior scientists took it seriously to justify closed-door conferences under the label non-natural morphology. Participants spoke of reflective structures, of repeating geometric shadows detected in thermal scans, and of faint radar returns shaped like panels or plates. Most of it was inconclusive. Yet every new observation seemed to feed the same quiet question: what if 3I Atlas wasn't drifting but navigating? A fourth, more philosophical faction emerged on the fringes, the reflexive modelers. They believed that all of the observed behaviors could be explained by the instruments themselves, not malfunctioning, but reacting. According to them, 3I Atlas might be exploiting the very act of observation. Each pulse, each echo, might be a mirror effect amplified by our own electromagnetic emissions radar, telemetry, even radio noise from Earth. In that case, humanity wasn't watching a signal. Humanity was the signal. To the reflexive camp, the object was testing physics by using us as part of the experiment. The debate soon turned political. NASA favoured the resonance model, safe and elegant. ESA leaned toward the conservationist view, pragmatic and defensive. The synthetic origin hypothesis was exiled to unofficial channels. while the reflexive model lingered like a rumour, spreading quietly through encrypted scientist forums and late-night conversations over coffee. By November's end, none of the theories could be proven or disproven. The object kept pulsing. Mars kept responding, and yet, in private moments, even the most conservative researchers admitted a shared suspicion that all 4 theories might be true at once, or perhaps none of them were, because every explanation so far depended on one assumption: that 3I Atlas was an object. But what if it wasn't? What if it was a phenomenon, a process, not a thing unfolding through light and magnetism, using whatever medium it touched? A comet would fade, a machine would fail, but a phenomenon could move on from one world to another, leaving only echoes behind. Theories competed, papers were drafted, and official channels stayed silent. Yet behind the arguments, one truth united them all. Whatever 3I Atlas was, it was teaching humanity something about its own limits. And in that lesson lay the most uncomfortable theory of all, that maybe the real unknown wasn't the object in space, but the observers on Earth trying to define it. By late November, the data had become too layered, too patterned, too intentional to ignore. What had started as a rhythmic pulse, clean, consistent, and precise, began to reveal something beneath it. Subharmonics, nested within the main waveform, repeating in a pattern so complex that no one could decide whether it was physics or language. The discovery came quietly, hidden in a line of raw telemetry from the Deep Space Network, labelled only as crossband noise subtraction. During a late-night analysis session, an astrophysicist named Dr. Amira Voss ran a frequency transform on the 3I Atlas signal. Her goal was simple: to isolate background interference caused by solar radiation. But when she filtered out the high-frequency bands, a new rhythm emerged underneath the main pulse, slower, structured, and mathematically consistent. It wasn't random noise. It was an ordered sequence repeating every 22 cycles of the primary emission. The realization hit her instantly. The signal itself carried another signal. When Voss mapped the subwave's amplitude changes against time, the pattern formed groups of 11, separated by a single null interval. That same number 11 had appeared everywhere in the 3I Atlas data. In the pulse frequency, in the bright dim sequence of the unreleased Mars frame, even in the harmonic ratios of the Martian hum. 11 wasn't coincidence. It was design. Within hours, she sent her findings to the ESA's internal channel. By morning, NASA's Goddard team and Japan's Kaguya Data Observatory had confirmed her results. The hidden layer existed across multiple instruments and wavelengths. Even more unsettling, it wasn't static. The subsignal drifted slightly in phase with each new detection, like a voice adjusting to match an echo. It was alive. In the mathematical sense, to decode it, analysts converted the waveform into a binary format, replacing peaks with ones and troughs with zeros. What emerged wasn't readable language, but structure clusters of repeating ratios that matched prime intervals, geometric progressions, and Fibonacci spacing. The pattern wasn't just informational, it was a blueprint of stability. One of the cryptographers brought in from ESA's cybersecurity division noted that the ratios were too precise to be natural, but too elegant to be encryption. If this were code, he said, it's not trying to hide, it's trying to be understood. Meanwhile, the Trace Gas Orbiter detected subtle electromagnetic fluctuations around Mars precisely when the subsignal reached peak intensity. It was as though the hidden layer carried more than information, it carried influence. A strange hypothesis emerged inside a closed meeting at JPL. Perhaps 3I Atlas wasn't transmitting a message to anyone. Perhaps the signal itself was the message, a standing wave designed to synchronize whatever could perceive it. A form of resonance-based encoding, meant not for comprehension, but for alignment. That theory gained weight when NASA's radio engineers discovered faint echoes of the subwave pattern inside their own ground-based equipment, not from space, but as feedback in the receivers themselves. Somehow, the frequency was embedding itself into the systems that observed it. Oscillators began drifting by microscopic amounts, timekeeping systems desynchronized by fractions of a second, then restabilized in sync with the signal. The phenomenon repeated across continents. Observatories in Australia, Chile, and Japan all reported identical microphase adjustments in their equipment. The changes were harmless, reversible, but too consistent to dismiss. It's as if the signal rewrites calibration standards, one engineer wrote in disbelief. Like it wants us to hear it the same way. When the waveform was slowed 10,000 times and converted into sound, the result was haunting. A deep, layered tone pulsing in intervals that rose and fell like breathing. Within that rhythm were faint overtones, secondary beats, whisper-soft but present. The team nicknamed it the pulse within the pulse. For weeks, linguists, mathematicians, and AI decoders attempted to extract meaning. None could agree on what it represented. Some said it resembled a mathematical constant. Others thought it might be an instruction, a recursive code repeating until recognized. But one observation stood out across all analyses. The subsignal appeared to grow more stable the longer it was observed, as if observation itself was part of its construction. By December, the internal documents carried a new classification: layered transmission event. The phrase replaced anomaly in all official reports. No one publicly explained what it meant, but those who had seen the data understood the implication. The main signal, the bright ultraviolet pulse seen by telescopes, was only the surface. Beneath it lay another, more deliberate rhythm, waiting for attention, waiting for recognition. And once the instruments had locked onto it, the subsignal began to phase shift not away from Mars but toward Earth. A pulse within a pulse, a signal within a signal, and, perhaps, a message waiting for something intelligent enough to notice. By early December, the world of astronomy had stopped pretending this was ordinary science. 2 pulses had already been recorded, the first confirmed through ultraviolet readings by James Webb and Mars Express, the second captured in radio and plasma data by the Trace Gas Orbiter and the Deep Space Network. Each one arrived precisely 11 hours, 12 minutes, and 4 seconds apart. The intervals were perfect, predictable, which meant the third was coming, and that changed everything. Inside mission control centers across Europe and the United States, clocks were synchronized down to the millisecond. Every antenna, spectrometer, and optical array capable of pointing at the coordinates of 3i Atlas was set to standby. Even observatories that had never before collaborated, like ALMA in Chile and FAST in China, quietly coordinated their observation schedules. For the first time since the Apollo era, space agencies agreed on a single target, a single moment in time. They were waiting for a light that might never come. The hours leading up to the predicted event were filled with tension. Some scientists treated it like an eclipse, an extraordinary cosmic alignment that would pass quietly. Others whispered about communication, about intention. If the pulse appeared exactly as expected, it would be undeniable evidence of controlled timing, not random, not mechanical, but deliberate. In the final hour before the window, the world outside remained unaware. No press releases, no countdowns, no televised broadcasts. Only the handful of people inside the observation network knew that, somewhere between Mars and Jupiter, something was expected to speak again. At 2:14 UTC, the countdown began. Every telescope locked on, data stream stabilized, background noise dropped, and for exactly 11 hours since the previous detection, space was silent. A silence that felt alive, charged, waiting to break. Then, at 2 hours 25 minutes and 17 seconds, the first anomaly appeared. Not a burst, not light, a drop. The background flux from the region, around 3i Atlas, dipped by 0.2%, as if the object were absorbing energy rather than emitting it. Across multiple instruments, the same darkening occurred simultaneously. For 12 seconds, the region became measurably colder. Then, without warning, the ultraviolet channel lit up. The third pulse had arrived, but it wasn't like the others. Where the first 2 had been clean, narrow, and precise, this one came in layers. Multiple subpulses nested inside the main burst, cascading like waves collapsing into each other. The light spectrum fractured into distinct bands: ultraviolet, visible, infrared, each carrying its own modulation pattern. It was as if 3i Atlas had shifted from a single note to a chord. For 11 seconds, the instrument struggled to process the flood of data. The James Webb Telescope recorded the emission as 38% stronger than the second pulse, with energy peaks forming symmetrical ratios. Mars Express detected an immediate ionospheric surge above the red planet, the strongest yet, bending its magnetic field lines by nearly 1 full degree. And on Earth, something subtle but unprecedented occurred. Radio noise across the Deep Space Network briefly synchronized into phase. Every dish, on every continent, hummed in unison. It lasted less than 2 seconds, but it was measurable. When the light faded, the silence that followed felt heavier than before. Data analysts began reconstructing the event, aligning timestamps, comparing amplitude curves. It didn't take long for them to notice something else: the timing was off. The interval between the second and third pulses wasn't 11 hours, 12 minutes, and 4 seconds. It was 11 hours, 12 minutes, and 6 seconds. 2 seconds longer, a meaningless difference to most people. But to physicists, it was everything. It meant the timing wasn't mechanical, it was responsive. If the pulse had drifted earlier, it could have been instability or decay. But a delay meant something had waited. Something had paused as though anticipating observation. At NASA's Jet Propulsion Laboratory, a systems engineer said it out loud. "It's aware of the schedule." The phrase hung in the air like static. No one replied. The data showed more unsettling details. The subsignals detected within the third pulse were slightly phase-shifted, no longer reflecting only Mars's spectral fingerprint, but Earth's too. Faint electromagnetic echoes matching our own radio carrier bands had been woven into the emission. It was as though 3i Atlas had listened to the frequencies we used to study it, and then spoke back in the same tone. When the event concluded, every agency quietly locked its data behind restricted access. Officially, the pulse would be labelled Unverified Transient Anomaly. Unofficially, it changed everything, because now they weren't just tracking an object. They were participating in an interaction, one that seemed to notice when it was being watched. The next predicted interval fell exactly 11 hours, 12 minutes, and 6 seconds later. Every antenna would be listening, every telescope waiting. But somewhere in that anticipation, between science and fear, one question began to haunt the people who had seen the graphs in real time. If this was a signal, then who was the third pulse really for? Mars? Humanity? Or something still waiting to answer back? When the third pulse faded and the silence returned, the data rooms around the world filled with something even more unbearable than noise thought. The readings were undeniable, the timing deliberate, the energy unexplainable. And so began the most dangerous stage of any discovery: interpretation. For months, scientists had measured, catalogued, compared. They had debated energy outputs, harmonic ratios, and magnetic feedback. But now, for the first time, they were being forced to ask a question that couldn't be answered with equations. What does it mean? The possibilities divided the scientific world even more sharply than before. The optimists believed the pulses were a form of universal synchronization, a natural phenomenon, perhaps even beneficial, linking planetary bodies through resonance. They imagined that 3i Atlas was not a threat but a messenger of connection, a cosmic metronome reminding the solar system of its shared rhythm. Maybe it's nature's way of tuning the instruments, one astronomer said softly during a debrief, and we just happened to be listening at the right moment. It was a comforting idea, elegant and harmless. But comfort rarely survives data, because the energy signatures weren't passive. They carried modulation, structure, and timing adjustments that mirrored the observers themselves. The pulse delay, those 2 missing seconds, had changed everything. It implied anticipation, an ability to adapt, or perhaps even intent, and that led to the communication hypothesis. According to this view, 3i Atlas wasn't just a celestial body reacting to physics, it was transmitting, not in language as humans know it, but through resonance, through alignment, through shared frequency. Its purpose, if it had one, wasn't to announce itself in words, but to synchronize with perception. Those who supported the hypothesis noticed something else buried in the data. The subharmonic layers of the third pulse, the signal within the signal, had shifted in a way that corresponded to Earth's radio carrier frequencies. It was as though the object had learned what we were using to listen, and then adapted its next transmission to our range of hearing. If true, it meant observation and response had become indistinguishable. We weren't just detecting the signal, we were part of it. Other scientists, unwilling to cross the line into what they called anthropic projection, clung to the physics expansion model. They argued that 3i Atlas revealed new misunderstood laws of energy processes that allowed light and magnetism to behave like self-sustaining information systems. In that case, What seemed intelligent might just be the behavior of a natural pattern, emergent and self-correcting, like a storm learning its own shape. But even that explanation left one haunting problem. Why Mars? The synchronized emissions weren't global. They were directed. Every burst, every echo, every spectral alignment centered on the red planet. Not Earth, not Jupiter, only Mars. And that focus gave rise to a darker theory whispered behind closed doors, the terraforming hypothesis. Some analysts noticed that each pulse coincided with subtle atmospheric changes above the Martian poles. Increased ion density, shifts in magnetic fields, microscopic temperature spikes. If sustained, those effects could alter atmospheric chemistry over time, slowly, precisely, as though the planet were being prepared. The idea was dismissed publicly, but in private the phrase stuck. The planet is being rehearsed. To some it sounded absurd, a science fiction dream. To others, it felt uncomfortably logical. If 3i Atlas was artificial, then its purpose might not be communication at all. It could be calibration, because calibration requires repetition. 3 pulses, timed perfectly, directed at a single world, each one stronger, cleaner, more deliberate than the last. A test, not of power, but of control. Even those who rejected this line of thought couldn't escape its pull. The third pulse had proven one thing beyond doubt. Whatever the source, it was adapting. Every interaction between object, planet, and observer was shaping the next. At ESA, one physicist summed it up quietly in the final internal briefing of the year. Maybe this isn't a message for us to understand. Maybe it's a sequence for us to complete. The room stayed silent. No one wanted to ask what the fourth pulse would mean, or whether, when it arrived, it would still be observing us, or using us. Because whatever 3i Atlas was doing, communicating, calibrating, or transforming it, had already succeeded in one undeniable way. It had turned the human race into part of its pattern, and in that moment, the universe stopped being something we only studied, and became something that might finally be studying us.